Hey everybody, welcome back. Today we're going to start moving into Chapter 7. Really the big concept of Chapter 7 is I'm going to give you a shape or a picture or something. And we're going to be able to talk about and describe how those pictures or shapes move in kind of your coordinate plane or what you guys would call a graph. So 7.1 just talks about rigid motion in a plane. So there's three motions that we're going to talk about. They're going to be called a reflection, a rotation, or a translation, and I'll talk about those more in depth in just a second here. But right away, okay, we start with an original picture and then the picture you get after you either do that reflection, rotation, or translation. Okay? The picture that you get after you have done that is called the image. The original picture is going to be called the pre-image. So how I keep these straight, I literally just think it through. Am I working with the image or the pre-image? Okay? Using the prefix of pre, meaning before. So the before image is kind of how I remember that one. One thing that you guys will need to be aware of, your book is going to talk about this being calling those reflections, rotations, or translations. They're going to say that it maps, okay? All that really means is maps just means moves, okay? So a reflection is going to map the pre-image to the image. So it's just going to move that image. And in general, these things, reflections, rotations, or translations, these are called transformations. So we're going to talk about three of them, okay? And we can talk about all of them. So overall, we're going to talk about reflections, which if you look down here, okay, you're going to reflect it just like a mirror. So it's going to end up being flipped over something. So you look here on the left, you have just the regular letter F. Okay, you rotate it over, or you reflect it over that line. I'm sorry, not rotate it. We'll get to rotations here in a little bit. You rotate or reflect it over that line, and it's going to look backwards because you flip it over that line. That's going to be your reflections. Okay, a rotation. Okay, the easiest way that I can describe this is it's a spin. Okay, if you spin it around, okay, so basically I connect my blue F. Apparently my smart board's not aligned very well right now. Okay, I connect my blue F to this point, kind of with this line, and I spin it around, and it ends up at that red F. Okay, so F would be my blue F would be my pre-image, red F would be my image. Okay, and then a translation. That is a fancy math word that we have made that means slide. Okay, all you do is you slide the blue F to the red F. Okay, it doesn't rotate, it doesn't flip, it doesn't do anything fancy. It just slides one way or another. So overall, what we're going to do, we're going to take a look here, give you a graph here. And we're going to use the graph of the transformation to the right. First of all, we need to describe and name and describe the transformation. Okay? The first thing we need to do is we need to figure out which one is going to be our pre-image and our image. And I will give you a hint because you don't always get things that are blue and red. Okay? Maybe I run them off in gray like the colors or like the papers you're looking at now. Okay? They look the exact same color. Okay? If you have that situation, okay, these little marks up top, A, B, and C here have apostrophes. That is always going to be your image. Okay? So on the left, triangle ABC, that is going to be the pre-image. And in math, we say those apostrophes, we call those prime. So this vertex down here, apparently wrong spot, okay? I would say this is A prime. Is how I pronounce that. So when I start talking about triangle A prime, B prime, C prime, I am talking about this red triangle. So now, I got to ask myself, what did I do to get the blue triangle on the left, that pre-image, over to the image? Okay, so it doesn't look like I rotated it, so I can kind of throw that out right away. Now, I'm only left with reflections or translations. Okay, the key to this here is that A goes to A prime, so that's going to match up here. Okay, if I were to just translate that or slide that over, A in my image would still be on the left. So A and C have flipped spots, which means that for part A, the only one that we have left is a reflection. Okay, and it's nice to say what line you're reflecting over. Your book is going to say in. I say over. We mean the same thing. So I'm going to say the reflection in the y-axis. Okay, meaning a reflection over the y-axis. Meaning I just flipped it over, which is, hopefully you guys can kind of see that here. We need to name the coordinates of the vertices of the image, part B. So the image, I can see that I have A prime at the point 2, 3, 4, 1. So I went to the right 4, up 1. Okay. B prime went to the point 3.5. Okay, and I'm just getting these from looking at the graph and counting. And C prime is at the point 1, 1. Okay, so naming coordinates, not so bad. And the last one is ABC congruent to its image. So is the blue triangle, are the red and blue triangles congruent, meaning do they have exactly the same? I'm going to say yes, they are. And if you would like, you can use the distance formula. And SSS to show congruence. So that SSS from chapter 4, talking about showing all 3 sides of triangles are congruent to the same 3 sides of another triangle, means that they're going to be congruent. So a little flashback to chapter 4 there for you. So ends up being congruent there. One other thing we're going to talk about here is it's called an isometry. So what that really means is that the transformation, whether it's one of those reflections, rotations, whatever transformation you are, if it is an isometry, that means that it's going to preserve length. So sides are not going to get bigger or smaller by doing whatever transformation you're doing. They're also going to preserve angle measures, parallel lines, distances, all of that is going to stay the same. So we call these rigid transformations, meaning things are not going to change size on you, which is good. That makes things a little nicer for you. So looking at an example here, which of the following transformations appear to be isometries? And hopefully this shows up better on the video than it does on the projector that I'm looking at right now. I know it shows up okay in your own notes. So which one of these are isometries? So they tell you which one is the pre-image and the image, so that helps. So looking at A, on the left I have my pre-image, and on my right I have my image. All I have to do is ask myself, do these look like these are going to be the same thing? So that's got to be that. This here has to be this here. These sides have to match up, meaning that the other two have to match up as well. And I would say so. Yep, that's an isometry. So this is an isometry. Sides appear to stay the same length. B, looking at my pre-image, my image. On the left, I have my pre-image. On the right, I have my image. Okay, do my sides all seem to match up? And I'm going to say no. I'm going to say this one on the right looks a little smaller, at least to me. So this is not an isometry. Because side lengths change. And the shapes are not congruent. So side lengths change, not an isometry. C, going from pre-image to image. Looks like I got a little bit of a rotation going on here. So do I think everything looks the same length? Yeah, I think it does. So this is going to be an isometry. For the same reason that A was, because your shapes are congruent. Meaning side lengths stay the same length. Carpentry. You're assembling pieces of wood to complete a railing for your porch. The finished railing should resemble the one below. So going a little above and beyond here, making a real nice railing here. First of all, how are pieces 1 and 2 related? So you can see those, and I believe they show up really well on your own paper. So how are pieces 1 and 2 related? Well, it looks like to get piece 1 here, okay, again, we'll kind of try and draw off some of my art skills here, and that didn't really work that well. But hopefully you can see those a little better. I'll get rid of that so maybe you can see them better on here. Okay, hopefully you can see that those two, all I did was I spun piece 1 around and I flipped it upside down. That's how I got piece 2. So that's just going to be a rotation. Pieces 3 and 4. They look very similar. However, they're opposites. So not going to be a rotation, not going to be a translation. Therefore, this has to be a reflection. In order to assemble the rail as shown, explain why you need to know how the pieces are related. So it allows you to manipulate the pieces to get the desired pattern. So knowing that, you can fit the pieces the way that you need to so that you can make that pattern match there. All right, guided practice. Obviously, I can't stop the video. Well, I could. I'm not going to just sit here, wait 5 minutes for you guys to work on these. So pause the video, try and work on these on your own. You guys can work in groups if you're watching together or whatever. So go ahead, pause the video, come back, and then I will walk through these with you once you guys have these done. Okay, first one. Hopefully you guys have tried these already. So we got to name the transformation that maps the blue pickup, the pre-image onto the red pickup, which is the image. So, okay, all I did was I moved the blue pickup in number 5. All I did was I slide it up there. Since all I did was slide it, that is a translation. Six. I flipped it upside down. Okay, so I either am dealing with a rotation or a reflection. So if I notice, everything seems to kind of line up vertically. So this window lines up here. Okay, you kind of see how the points line up. So all they do is they just change where they are up and down. So that is going to be a reflection. And 7. Okay, process of elimination would tell me that this has to be a rotation. But you can see how 6 and 7 differ, whereas these windows don't really line up. I've got to actually, if I spin the truck, that's how that's going to get there. So that's going to be my rotation. Using the figure shown where QRST is mapped onto figure VWXY. Okay, so all that means is this is going to be your pre-image, and this is going to be your image. Okay, the arrow right here kind of helps with that too. So, first of all, name the pre-image of XY. Okay, well, XY is right here. Okay, if I were to rotate this over, so Q is farthest away from this line here, so that's got to match up with V. So I got to look at the piece that's closest to the line. So that means that I have to work with ST. We need to name the image of QR. So QR, again, farthest away, R is up top. V is farthest away, W is up top, so that has to be VW. And we need to name 2 angles that have the same measure. There are a lot of options here. So you could have angle V and angle Q. You could have angle S and angle X. And you could also have these split angles here, RTQ, being congruent to W, angle W, YX. And I've got these angles here can be congruent. Really, any angles that you pick are going to be right here. So I'll just do one more example. I'm going to go angle VWY being congruent to angle SRT. Again, and if you picked one of the other split angles, that's fine. Those should be congruent as well. Just make sure they match up. Actually, VWY should not RST. It should line up with WXY. No, not WXY. RQT. Again, wrong again. Okay, V matches up with Q. Sorry, just got to make sure I get things in the right order. Q, RT. There we go. So those two angles match up. And name a triangle that appears to be congruent to triangle RST. Try and pick a color I haven't used yet. RST right here. Okay, well, that is the close triangle to the closest triangle to the line. So I'm going to pick the other close triangle to the line right here. So I'm going to go with triangle WQT. All right, you guys have the assignment on the back of this paper, or on this paper, I guess. You got to practice, and your assignment on the same one. So just match up things that seem to be the same. If you guys have questions, stop by, see me before school, after school, study hall, whatever. We'll get you squared around. If you need to shoot me an email, feel free to do that as well. And I'll try and answer any questions you guys have. So other than that, we'll check this when I get back, and have a good day.